Today's episode of The Coder Career is brought to you by the University of Birmingham's new front-end development course. If you're trying to make the jump into front-end development, UOB is offering a free 16-week part-time course to get you job ready and start a both satisfying and financially lucrative career in tech. If you're based in the West Midlands and you're aged 19 years or over, apply via the link in the description.
Hello, everyone, and welcome to another episode of The Coder Career with myself, Colin Riddell. I am a former instructor and software engineer.
Good afternoon, party people. This is Cameron Blackwood, the Coder Career co-founder, former technical recruiter, and current software engineer. And we are really excited for today's episode because I think I'm going to learn a lot today.
Yes, that's what we like. Can't wait. What are we talking about?
Yeah, I was going to say to you, what are we talking about? Kubernetes, right?
Yeah, we're going to talk about Kubernetes. Yeah, it's a pretty interesting one. I'm dead keen to talk about it. So yeah, what do you know about Kubernetes?
I'm going to be honest, not a whole lot. So, from what I
Okay.
understand, it's basically a way of managing virtual machines and scalability, whether that's horizontal or vertical. I can't remember,
Yeah.
but
Yeah.
essentially, it's a way of managing containers on virtual machines and being able to scale up and down your VMs with stuff like demand and requirements. So that's my very basic understanding of the whole thing. So I get the use case and I
Yep.
get the sell, but I don't get how it works.
Got you. All right. Well, we maybe don't have time to go into the how it works. But like we'll definitely chat about what it is and make sure that people have a really deep understanding of what it is, because it's one of those things that, like, I've discovered that a lot of people it's a bit of a mystical black box, in that because it is a quite a complex system, that in order to understand what it is, you need to understand what a couple of other things are, as we'll explain. And I think that means that some people think it's a database. Like, some people think it's like I think you were saying earlier. Some people think it's a programming language. So yeah, we'll give that stuff a bash. We'll just get cracked straight into it then. Yeah.
Yeah, certainly when I was a recruiter, I remember no one understanding what it was and everyone panicking. I think even pronouncing it, I don't think anyone knew.
Yeah. Yeah.
Even now, as a regular software engineer, it is still very mysterious. But I guess it need not be that way.
Nah, definitely not. Definitely not. Um, and remember the thing that people used to always have trouble pronouncing was, like, people used to always argue about Linux versus Linux, but that's a whole other
That is a whole other
thing for
episode.
another day.
And let's not get
So
started on GIF and GIF.
Geff and Jeff, yeah. Oh my god, yeah. What was it that one of my lecturers at uni used to call it a? He didn't call it a. He didn't call it a pixel. He called it a poxel. So I don't know. That's
I
a
mean,
whole
that's
other.
just wrong.
Yeah, I know. So let's get stuck into this Kubernetes thing and not waste people's precious time on telling them what it is. So the thing about understanding Kubernetes is that in order to understand what Kubernetes is, we need to understand two really important pieces of information, right? The first thing we need to understand is the concept of multi-tenancy. And the second thing we need to understand is virtualization, right? So, what we're going to do as part of this explanation is we're going to not talk about Kubernetes for like the first 10 minutes. And we're going to talk about these two concepts: multi tenancy and virtualization. So, what is multi tenancy? That's the first thing we need to get into. Multi tenancy is this idea that you should be able to run um, that lots of people can run their app on one machine. Now, let me try and explain. So, let's say you get a server and you run your code on that server. And generally, when we get a server, like, because that's where when we ship our code to the internet, that's where it ends up running, right? Like, that's something we need to all just be comfortable with. When we put that code on, that code goes onto that server to run, it's running on a machine, a computer with other people's code running on it, right? So back in the day, like 20 years ago, to put something out on the internet, to publish our our application, our web app, we would for example, we would either buy a server or you would rent a server in a data center, and then they'd give you like direct access. You'd have full tenancy of that machine, right? So you'd be able to like remotely access that machine. You'd install your application. You would basically have you could do whatever the hell you wanted about that machine, within their terms probably, but you'd buy a
Nothing
physical
illegal.
machine and
Yeah.
well, yeah, or maybe you'd sign something to say that if you do something illegal, it's not their it's not their problem. Um, so what the problem with that though is that if you take your one app, right? Let's say you've written an app in Python, okay, and you've rented this machine, this big beefy server. Um, that ends up being a fairly costly way of like running your application. Now, let's not go to we know that the cloud, which is the thing that comes later on, is costly, but let's not take that argument into account too much. So but it's more costly for the person who is running the server and is renting that out to you, and that like you've got one tiddly little app which might not even be getting a a ton of hits or a lot of usage, but it's using a big beefy server. So um, multi-tenancy is the idea that you make a system somehow that makes it so that when you go to rent someone a server, you actually rent them like a sectioned off space of one big server rather than them renting you something that's like the whole thing. um and this means that you move away from this idea that you have one physical machine per application, which is genuinely how things used to work, right? And we move towards a system where we have one application, sorry, we have one physical machine, but it could be running lots and lots of different applications. Now, you may be asking why? Why is that? Why is that important? And the reason that's important is because it's really feasible within reason for you to write some code in your app which could read all of the data on that computer, right? Like that's not a difficult thing for someone of a medium coding ability to be able to like even figure out how to do. You write part of your Python code to like skim every single piece of like data off that hard drive to like pull all the data out the RAM, like send it to you, and if you've got two applications that are running on one server, and one's from customer A and one's from customer B can steal customer A's data, right? So this is why multi-tenancy exists. It exists to make it so that two people, two companies, two entities can run their app in a server, but not have to worry about their data being stolen by someone else. And not only that, but they're like, what if one's Bitcoin and mining and the other one's just sitting there doing nothing? Let's to do with the term usage policies and stuff as well. So that's what multi-tenancy is, and virtual machines are the way in which that was solved. And of course, you'll have heard of virtual machines. You kind of mentioned them earlier on as well, right?
Yeah, exactly.
Yeah,
Yeah.
yeah. So virtual machines solve the problem of multi-tenancy. They solve the problem of multi-tenancy by making it so that you basically take one big physical machine, but you run specialist software on that physical machine that essentially partitions every part of the machine. It partitions the CPU, it partitions the hard drive, it partitions the RAM, it partitions everything into two. And then what you do is it's specialist software that runs on top of runs on your computer, but it runs on the computer, and it makes it so that those are almost like it, little virtual. It's hard to describe, little virtual machines within the machine, uh, and they're like a soft version of that computer. Now that means that you could have like a physical server, a laptop, or whatever, your desktop, your gaming PC, or anything could be your host machine, and it could have one VM that runs on it. And in that VM, you could have a completely different system. So, for example, you could have like a Windows machine with a Linux VM on it, or you could have a Windows machine like with like 3 or 4 Linux VMs on it, or a Linux machine with 3 or 4 Windows VMs on it. The only one that people have never really quite cracked how to do properly, and I'm pretty sure you can probably do it by now, but it's a bit fiddly, is running Mac as a VM. So you can use Macs to host VMs, but it's really difficult. It's really difficult to run Macs as VMs.
I think one of the big cloud computing providers does offer Mac now, but it is like Mac OS, but in limited terms. Maybe it is literally just running on Macs. Um, but yeah, I think it is very cool because I've done that before I've run Linux VMs on a Windows machine, but people do need to remember to shut them down, otherwise they will eat that RAM like nobody's business. But yeah, I feel like when you were looking for the word, I wondered if you were looking for the word containers, and that might be a
Nope.
segue, but no.
I'm afraid not. That would definitely muddy the waters in terms
Yeah.
of confusion. Like 1 minute you're talking about this. So VMs are like amazing, right? Like, but and they're still used today. Um, they're still very much a prevalent part of the cloud and like our modern infrastructure for building servers and services. They're not used anywhere near as much as they used to be because of things like containers, as we'll get onto. But basically, VMs, as I said before, they take a physical machine and they break it down into so that you can essentially have lots of software defined machines that they have no way of interacting with each other at all. They're like so they're completely isolated. You know, like the memory space that your application runs on VM A isn't the same memory space that your application runs on VM B. Like the hard drive isn't the same hard drive. I mean, it is, but it's not like physically the same. It's not like it's physically the same hard drive when you like pull out in the grand scheme of things. But in terms of their little environments, to them individually, there's nothing that's shared. And so it is physically the same hard drive that you're connected to and that people are putting their data on. So if there's a machine with one hard drive and then that's split between two virtual machines, it's still physically the same hard drive that the data goes on. There's no insane magic that means it's different hard drives. But if you are from the point of view of that virtual machine, there's no physical way of accessing the data on the other virtual machine's hard drive. In the same way, there's no other way of accessing the memory space of that other virtual machine, and there's no other way of accessing the CPU, like the virtualized CPU as well. So it's
So can I
completely
try an
completely walled
analogy
off.
here?
Yeah,
See
yeah,
if that
yeah, yeah.
works.
Absolutely.
So to explain it in real world terms to listeners, rather than like to give an analogy,
Yeah.
it's like a big storage facility where you rent
Hmm.
out a part of it, but you can only access that part of it, and you can't see what everyone else has in there, and you can't break into theirs because each is individually locked in this giant storage facility. So you have storage within
Yeah.
the storage.
Yeah, it kind of is, but like the amount of space that you get is depending on how much is allocated by them. So yeah, that's a perfect analogy. Cool, good.
Cool.
So
That's the
that's
promo clip
VMs.
sorted.
Yeah, yeah, yeah. That's VMs. So specialist software makes multi-tenancy possible. Um, so the one of the kind of issues that we've got here just to keep in mind is that your one physical machine can run like 1, 2, 4, 6, 8, like small numbers of virtual machines, right? Like there's an upper limit on the number of virtual machines that you can run within a physical machine. And that's really, really, really important to understanding why containers are important, which is what tells us the story of Kubernetes. So, one of the things we talk about as well is that when virtual machines came along, developers needed to deal with the complexity of running and maintaining virtual machines, which are actually quite unwieldy and clunky. And one of the reasons that they're unwieldy and clunky is because you, as a developer, if you want to deploy something onto a VM, the VM has an operating system on it, and that operating system is often the entire operating system for that application for that OS. So if you want to run like your Python app, And if you want to run it on Windows, you'll have full Windows there. If you want to run it on Linux, you'll have full Linux. And there's not really an easy way to like cut bits out and pull bits out, which is another reason that that's going to give rise importance to the more modern alternative. So with this virtualization, this gives rise to a category of services known as PaaS, Platform as a Service. So platform as a service is where someone else manages the configuration for you, right? So someone says, hey, I am going to give you a server. You don't know whether it's a physical machine or a virtual machine. You just get access to a server and we'll manage it for you. We'll manage the configuration for you. It's likely going to be a virtual machine, right? And there's a big company, VMware, basically specialized. Their entire business is based off of building virtual machine software for servers and for desktop as well, and that was for a long time, and it's, I suppose in some respects still is how applications are run. You know, you get some server space, but it's probably not going to be physical server space. You get a virtualized server space to run your application on, and this is PaaS, platform as a service, and this is kind of around the time that when this idea of platform as a service was born. That's really where the cloud started, right? So when it becomes easier to just be like rent a service, run your stuff, that's kind of where we're starting to see the beginning of what made up the cloud. And this is how stuff was built for quite a while. 15, 20 years ago, there are still quite a lot of applications that run that way. Very, very, very few of modern day applications are run that way now. Although we might talk about this later on. This might all go back to after that the 37 Signals blog that happened quite recently. I'll maybe chat about that in a wee while. So the problem with using VMs though is, as I said before, you've got a maximum upper limit on the number of VMs that you can stick into one physical machine. And you could probably get best case 15, 24 on a really, 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 really beefy machine with like 4 quad core CPUs, 128 gigs of memory, like a 3 terabyte SSD. Like these machines, in order to run that many VMs, they need to be beefy. Running a VM that runs nothing. Like if you spin up a VM on your computer and just run nothing on it, that it's still running something. So it's still using like 50, 80, 30% of your CPU, depending on how much it's using. And companies like VMware were trying to tackle that, and still try to tackle that by making it so that, for example, you could take VMs and scale them out, right? So basically, what VMware are trying really hard to do and manage to do is to fight this idea that the VM's scalability is bound. What that means is that basically VMs are bound by the confines of the physical machine that they run on, and they're vertically bound, which means in order to get more VM power, the only way to get is a bigger machine, as I said. So companies like VMware are trying really hard to like make it so that it scales horizontally, which means that you just add more machines. And that endeavor ended up being quite costly because that was a big research, kind of, project, and a lot of effort to make a network of computers appear like one computer, like in a really simplified sense. So that means that longer term, only really wealthy big banks and larger companies were able to really take advantage of that. So VMs were the solution to multi-tenancy. Multi-tenancy is this idea that you have multiple applications from multiple application developers all running on one machine. And that then sets that, now that we understand that then sets the stage for our understanding of containers. And I think now we've set the stage. We now know that, and we've got a kind of understanding that there's a problem here with. We've solved the problem of um, multi-tenancy through virtual machines, but we're realizing that virtual machines are quite clunky and heavy. So along comes an application in around about 2008 called Docker, right? And nearly every engineer has heard of Docker. And Docker gave birth to containers. Now, okay, there might be somebody out there that knows their history pretty well that says, well, actually, containers existed before Docker came along, and yes, technically that's true. The concept of what a container was existed before Docker, the company. Docker's a company, made it famous. And confusingly, Docker is a company, but the people at Docker invented the open source project called Docker, um, which may or may not be open source anymore. Actually, now that I think about it, I think it
I
probably
think,
is.
yeah, something changed on it recently, I want to say.
Yeah, I think maybe the license changed. That's all it is. I
I
can't.
think that might be what it
Do you know
is.
what I mean? Please do not take my fact. Hold on.
We'll
Hold
have a
on.
clarification in the description because I'm curious
We'll
about
have
that one now.
clarification. Uh, GitHub Docker.
Definitely not googling anything there.
Not googling anything. Looks like there is some repositories there, but I'm not sure if the actual core part of Docker is open source anymore. But I could be wrong, so please don't take fact in it. Anyway, Docker. The point is that Docker is the thing that was released in like around 2008, 2009, maybe, that brought containers to the forefront and said, right, here's what containers are. Um, Containers are a way of using multi-tenancy, so the same concept of running multiple separate, very separate um, operating systems that are contained on one physical machine. And containers are what Docker runs, and they run natively on that host, right? Now, what that means is there's no virtualization, and that means that it's significantly more efficient in every way possible. It means that the number of applications that you can run in containers, even though it's a similar concept to virtual machines, is vast compared to virtual machines. We're talking like one physical machine, like your laptop, could run maybe like 3 or 4 VMs really well, maybe five, but your laptop could run between 100 and 1,000 containers. Now, if those 1,000 containers or even more don't do much, they could do a whole lot more, um, and that's like a huge win, right? So we went from VMs, which are like these very isolated virtual machines, to containers. Now, containers are basically something that pretends that it's running in a completely separate operating system. Um, and what it does is Linux has got some magic that makes it so that it looks like to that container that it's the only thing like running on that machine, um, and that there's no way of like accessing what we call the host, which is the thing where the container runs on. But the great thing about it is it's just a normal like native process that runs on like that. Usually Linux. When Docker first launched Windows wasn't a thing. Um, Containers kind of primarily like exist in the Linux space. There is now support for Windows, and for on both sides. In other words, you can run containers on Windows, and my understanding is that you can also run Windows containers. But again, that might not be true. I've never actually done it, so I'm pretty sure you can though. And so basically, your container is like a very, 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 very lightweight version of what a virtual machine does, but it doesn't do any virtualization. And actually, in actual fact, what you can do is if you're on an operating system which is running some Docker containers, it's possible for you as the person who owns the host to like find where the files are that those individual containers like are using, but they're like deep, 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 deep into the machine, and they're designed for you to never be found. Now, you could say, "Oh, that's privacy," blah blah blah, but the way that multi-tenancy works is that the host can at least with the containers, the host can see the container's data, but the containers cannot see each other's data or processes or anything like that. So that's the important kind of takeaway from that.
And that solves
So
the original problem as discussed, where you could write some kind of script to grab data out of the random access memory.
yeah,
And basically, let's assume that your lovely co-tenant on a virtual machine is stealing your payment details as you're
yeah,
processing them, and we avoid that problem, which I think we can all agree is a very good thing. Avoid
yeah,
not
definitely.
we don't condone sign it.
We got you. So the this is what containers are now. It takes a little bit of time to like quite get that in your head. I think for a lot of people, and it can be one of these things that someone explaining it doesn't really help. But one of the other things that's really important about containers is that they they allow for reduction in the OS, what we call image. So the OS image is like all the files that are used to install the operating system that VM or container will use. So back in the day, for example, like when we had VMs, you would. This is maybe a good way to think about it for some people. If you wanted to install like a Windows VM on your whatever machine, you would physically take your Windows like CD-ROM that had like Windows installed on it, and you'd put it in the computer that you wanted to put the Windows VM on, and then you would say like to the VM manager, make me a VM from this disk. Another way to think about that is an image. Eventually, you could download like what we call ISOs, like that are basically like an ISO is basically like a disk that you like can download. It's insane. Um, they're not as common as they used to be, but if you want to install a Linux OS, that's how you do it. And kind of what and they're referred to as images. So what containers do is they take that concept even further and say, right, a container is made from an image, but then they rip it all apart in a really good way. And what they do is they take something like a big Linux image that's maybe got like a gig and a half worth of like random crap in it, like the 64 languages, a bunch of stupid, useless games that nobody really wants or cares about, a bunch of like utility apps that nobody wants or cares about. And what they do is like they rip that out, right? This is the great thing about containers, modern day containers, is that the images can be highly customized. So what you can basically do is you can take out all the stuff that is not needed, except the bits that are needed to run your app. And that's really, I want to let that settle in people's heads because that's really, really powerful. What that means is you can then basically download, you can go onto like what's called Docker Hub, and you can download a bunch of images or an image that has all of the stuff that you need to be able to run Python or Redis or Java or even WordPress or even like a bunch of like other types of servers that I can't think of right now. like, so we've now got
WordPress,
to the
if you want to
stage.
suffer through something like that, then feel free.
WordPress is popular. Not gonna go there. But the point is that we now have a system where you can customize these things within an inch of its life. You know, you give me enough operating system guts just to be able to run Node, and that's all you need. So we've basically went from running 4 to 8 separate applications per machine, where now we can now run like 100 to 1,000 applications per machine. So once you like scale that up, you've then got tons and tons and tons of like separate applications per machine. But these applications aren't just applications; they're entire operating systems. A container a, is basically an entire operating system, albeit a stripped down operating system. It's got very little in it. You can literally spin up a container and you can what we call shell into it. You can SSH into it or get access to it. And you can look around in there, using the command line, cd, ls, etc. And there's nothing there. Like that you'll be like there'll be like a lib directory, a bin directory, like a user directory, and a bunch of other basic Linux stuff that Linux needs. Who knows what Linux needs. Um, and that's all that'll be there. And then there'll be your app. And then we've now really just unlocked some really, really great features of how we run applications in a modern kind of scalable sense. Make sense?
I'm definitely going to do some reading up on this after the show, and I think it's probably a good idea if the listeners do as well if they're not familiar
Yeah.
already. You were mentioning to me that YouTube channel the other day that you said is basically the
Mm.
authority in Kubernetes. What was that one again?
It's became authority in Kubernetes. This YouTube channel is called Tech World with Nana, and she's like an amazing DevOps and Kubernetes and Docker software engineer who's done some of the best like tutorials and concept videos on both Docker and Kubernetes, like in recent times. Absolute authority, as you say.
And if she's listening, do come on the podcast and teach us about Kubernetes as well. That would be cool.
Absolutely. So, yeah, containers are little native processes that run on your machine, and they themselves are entirely like they're whole operating systems in their own right. So we now know what multi-tenancy is. We now know what VMs are. VMs, by the way, are still very much used in data centers and in cloud computing, like everywhere. Like you can still rent VMs, you can still buy VMs, you can buy physical machines, you can rent physical machines, and most of the stuff that runs on the cloud runs on VMs. And the reason for that is because um essentially like companies like VMware have basically made it so that you can control your entire data center using VMs, and you can basically like software define everything. You can just have a bunch of machines that are networked together, and you can say, right, these machines do this, or every second machine works this part of the data center, every third machine works with this part of the data center, and it's really good for like resiliency and all the rest of it. So please don't be fooled into thinking that VMs are like old school and redundant. They've just moved down a layer to the point where we as application developers no longer see them. They're very much in use, and they're very much still there. Um, and actually, ironically, like you need some quite cool hardware on your computer to be able to run VMs. I don't know if you remember when I first met you, you had this problem with your
Oh,
desktop that you couldn't you couldn't install Docker, which uses a VM, ironically.
yeah, I couldn't use
Um,
virtualization.
yeah, because you had to enable the virtualization. So
That
basically,
was a
the way
very
just
boring day fixing that. Do you know I
yeah.
actually ended up? I mean, I did fix it, but something else went wrong in that computer, and I literally ended up raging so much on a Saturday afternoon that I unplugged it, stripped everything out of it, and eBayed all the components. Like
You're
I was just so
joking.
fed up with it. Yeah, yeah. Honestly, I swear to God.
VMs are good, honest.
It
All
wasn't because
right,
of that. It was something else that happened to it. There was a. I'm not going to bore the listeners, but there was a problem with the processor or something. I can't remember.
right. There must have been, because basically the quick takeaway from that little side note of information is that despite the sweet awesome power of virtual machines, and how they're still very much widely used, they actually need some pretty sophisticated hardware on the CPU level to work. Their Intel has a whole host of uh, VX type instructions which only virtual machines can really access and use. So yeah, there's some pretty cool stuff going on there. Um, so we now have containers. We now have virtual machines. We understand what multi-tenancy is and all the rest of it. But now we have a bunch of other problems, right? So um, people now have are running all their applications in containers. They're probably getting to the hundreds of containers, for a big application. Now they need some other things. For example, how do we connect different containers to different networks? How do I say, for example, I want these containers which are dealing with payments to not be publicly accessible? I want these containers that are dealing with like the front end to be publicly accessible. How do I say run some like run all these containers together, but load balance between them, which means like share the load between them? How do I, for example, um, make it so that if I've got a bunch of physical machines or a bunch of VMs, and I want to like run containers on all of them, but make it look like one big like pool of containers? How do I do that? And yes, finally, the answer to that is Kubernetes. So Kubernetes is the answer to basically all of those three those three questions. And on the high level, Kubernetes is how you organize and manage and control lots of containers, as well as how they do things like access the internet, speak to each other, hide from each other in terms of networking, how they access databases, how they treat like lots of things to do with stuff like that. So like it basically Kubernetes allows you to like run containers, but in a way that you can have multiple physical machines that are all connected. You could literally like take two laptops or two desktops and network them together like in your house and run Kubernetes on both of them. But what it looks like one big it would look like one big machine where you can just run lots of containers. And Kubernetes will automatically manage and balance between those two machines, which is really, really, really good from a physical redundancy point of view. So before Kubernetes, it wasn't easy to have that level of redundancy. So it wasn't easy to share containers between multiple machines. And Kubernetes, lets you do that, and it also helps with the scalability aspect. So the scalability aspect is, like I said, if I've if it comes to Black Friday and I've want to run a bunch of like payment applications, I want to be able to scale those up, which means I want to get more instances of that. Kubernetes does that for you completely out of the box. So you can basically say, I want to run between 0 and 100 um, payment like pods, or we call them pods in Kubernetes, but they're containers. Um, and then it'll like automatically scale up um, based on some like CPU requirement or some RAM requirement. Um, and as well as that, it lets you highly customize all the networking. So you can say like, I want this little pool of containers to all take roots in from this endpoint. I want this little pool of containers to take roots in from this endpoint. So, for example, the codercareer.com slash, I don't know, let's think of something, blog. This isn't what happens, by the way, but codercareer.com slash blog could, for instance, be rooted to a bunch of containers that deal with the blog. That's not how it works, but it could be. And then slash um, uh, Discord, the little thing where you type the thing in to go to the Discord, could, for example, run off a different set of pods. Now, that is actually realistically not how it works. That wouldn't be a good application, but the theory's there. Makes sense.
Kind of. Yeah, it
Okay.
more or less makes sense to me. Yeah.
So the final thing about Kubernetes is that it's really important to talk about the microservices pattern. The microservices pattern is this idea that that we we like, or some places and a lot of places, but not everywhere, they favor the idea of running a lot of independent services so that they can scale, right? Like the microservice pattern is all about making things scale. And what it is, you know, rather than having one application where a bit of the application deals with payments, a bit of the application deals with deliveries, a bit of the application deals with the front end, but it's all one physical app, like with one code base. You have separate physical, separate apps that run independently, and that fits extremely well with what Kubernetes offers, because Kubernetes allows you to say these containers, as I said, are doing this. These containers are doing that. Off you go. As long as you know where each other live, you know how to call each other, then we're good. And that's, in a nutshell, that's kind of some of the kind of concepts behind the basics of what microservices let you do. That way, as I said before, when there's a when there's a big uptake in payments for a particular day, that means that the payments containers can scale. In other words, they can increase the number of containers, because we don't have a way of increasing the physical size or the amount of memory they're using. It's not a good pattern to do that. And then Kubernetes is a really is a really good fit from that point of view. So that's what Kubernetes is. Um, I guess the next final question, and we'll try and wrap it up, is how do you work it as a developer? And it's easier. It's easier than you would think. The way that it works, the way that you interact with Kubernetes is that once you've set up what we call a cluster. So a cluster is basically like um, a pool of one or more machines, physical, virtual. You can either run them on AWS, you can run them locally in your front room. You know, you install Kubernetes on those machines and you configure it so that they find each other across the network, basically. And then when you run commands on it, you're running commands on your node pool, which is like one or more machines that are all part of this cluster. And then each application you write. So if we're writing, if we're writing a like, let's make it more realistic. We're putting together a Discord bot, right? If you're writing a Discord bot, then your Discord bot has a deployment, and that's a Kubernetes term. And then if you're writing a web app, your web app has a deployment. And in those deployments, you define what the containers are and you define any other properties about them that you want. And then the next thing you do is you define what they call a service. So one of the slightly confusing things about Kubernetes is that your your nomenclature, your terminology has duplicates. So there is, for example, as I said before, there's a concept in Kubernetes called the deployment, but there also is a concept in just general, computing called deployment, and that can be quite confusing. And there is also a thing in Kubernetes called a service. Your service is a really powerful part in Kubernetes, and what that does is that you apply a service to your deployment. So you make a deployment for our Discord bot, and out of the box, that deployment can't speak to nobody. It can't do any internet. It can't do any networking at all. Then you give it a service, and the service lets you do the networking part. And for example, the service could say, "Give me a public IP address. Give me a private IP address. IP address. Give me a public and private IP address." Oh no, don't give me either, and just let me use the IP address of the host. So lots and lots of things can be done with the service, and it's the thing that gets attached to the deployment to give it network access. And you kind of build up the puzzle like that. And the way that you do that is that you write YAML files, and you write YAML files to define those things that I just mentioned, and you store those YAML files basically in the code base alongside your application. So you write a bunch of Kubernetes YAML files, store them in your application, and then you can basically use a command line tool called kubectl. It's KUBECTL. It's I think it's short for kube control, but people just refer to it as kubectl or the cuddle command,
Do
which
you
is a
know
bit
what YAML is short
weird.
for?
No, I don't actually.
So it's changed twice. This is I quite like this story. So they started off as YAML, yet another markup language, but
Oh, cool!
then
Didn't know
they
that.
felt that the scope had changed a little bit. So now it's a recursive acronym. An acronym, acronym.
Yeah, I got what
It's
you
a
mean. A
recursive
recursive acronym.
acronym,
Yeah.
and now it is YAML ain't markup language.
I like
Yeah.
that. I didn't know that. That's very cool. I'm writing YAML all the time, but I had no idea what it
Yeah.
stood for.
Yeah, me as well with pipelines. It is a
Yeah,
YAML is pretty easy to get up and going with actually. You can even take
yeah,
notes in it. Like maybe
yeah.
that's a bit weird, but I find sometimes YAML is quite a nice little format to take notes in.
And it can be converted to and from easily from JSON as well, which is quite good. You can actually interface. You can control Kubernetes with either YAMLs or JSONs. People tend to go for YAMLs.
Yeah, that's what I've
I
seen
don't
as
know
well.
why. Maybe they're a little bit easier. And then the final thing is if you want to learn any more about Kubernetes, one of the one of the kind of slightly more advanced things to do once you've started learning a bit of Kubernetes is to look into a thing called Helm. And basically, writing a bunch of YAML and copying and pasting it is laborious. And what Helm does is Helm templates it and makes it so that you can say, right, spinning up another microservice. I just like reuse this template, and we're off to the races, and I don't have to rewrite my YAML. Um, and then that all goes into your source control. Yeah, and that's it. And how Kubernetes actually works is it's a big Go application. Um,
Oh, like Golang.
writ- yep, it's written
Hmm.
entirely in Go. Um, it's pretty big. It's fairly beefy. It's open source, and it's invented. It was invented primarily, by Google. Google were the inventor of it, and obviously, it's now, a kind of well, well known uh, open source project, but still obviously is maintained very closely by the Google folks. So that's your Kubernetes. It's the thing about Kubernetes, as I said before, is like it's tough because you have to understand what problem VMs solved. And then you have to understand what a container is and a little bit about what Docker is in order to really get what Kubernetes is and does. Um, but it's pretty nifty.
No, not to put you on the spot here, but something that's been
Go for it.
springing to mind for a while since we've been talking about this is quite a difficult one to practice because you can make a React app at home pretty easily.
You're spot on. Yeah.
How can someone who's listening now be like, okay, this sounds awesome? Because also as well, jobs really look for people being able to understand Kubernetes. How can
Yeah,
people
at the
practice it
mid
at home?
yeah. I think that is such a good question, man, and I've been thinking about this a lot recently, and it's really, really hard to answer. There is a project out there called Minikube, and Minikube, what Minikube lets you do is it lets you run Kubernetes on your machine. It lets you run an entire Kubernetes cluster on your machine. But here's the sucker. Minikube, if you were to run it on Mac, Minikube is for Mac, and the reason that it's for Mac is because you can't actually. This is going to get a little bit inception-y. You can't actually natively run. Yes, this sounds ridiculous. You can't actually natively run Docker containers and therefore Kubernetes on Mac natively. So, like, if you were to take a laptop and install Linux on it, you can install Kubernetes on it and you could use it sorted, no problem. You're dead easy. Well, not easy, but easier than if you've got a Mac. If you've got a Mac, you have to use a thing called Minikube, and that comes with Docker usually. I think these days, and it's difficult because that whole thing runs in a VM because Mac doesn't natively support it. So that ends up meaning that you can only run a few things on it before your machine starts to melt. And generally it's so difficult, like it's so clunky that it's uses so much, of the VM uses so much of your CPU and memory that it's really difficult and clunky to like do your work as well as run a Minikube instance. So if you want to play with Kubernetes, either use DigitalOcean, which is really good, by the way. I'm going to start plugging DigitalOcean informally. Got a really good cheap, cheap-ish Kubernetes option there. It's very expensive to run in AWS. It's quite expensive to run in Google Cloud. It's also quite expensive to run in
Azure?
Azure. Yeah, you can try out Minikube. It's pretty good, and but it is beefy. But if you've got access to native Linux, you can just install it straight on there and have at it. But that's a really good question because it is not one of these things that's easy to just, you can't just install it and off you go. There's a
Yeah,
little bit
unfortunately
more, a
not.
little bit more to it than that. But yeah,
Cool.
so
So
that
that
pretty much
is
wraps it up.
Kubernetes. Yeah.
Yeah, I hope it made sense to people. And as always, if you've got any questions, come and join us on our Discord and ask us. We'd love to hear if you thought that was useful, and if you have any more specific questions around Kubernetes. We're using it a little bit in the Coder Career, and that is thecodercareer.com/Discord.
Cool. Thanks so much for listening, everyone. And if you also, as well, just another quick plug if you have any questions you want to ask me and Colin on the show or any of our guests, there is also a link in the description as well where you can leave us a voice message. And we love getting those. And we do have a couple coming up, I'm sure.
That'd be great. Thanks, everyone.
Cool. Thanks, everyone.